That covers the axisymmetric plume for the near field scenario. Now let's have a look at the far field model. If it is a far field model, then this is a formula that you should apply to determine the mass flow rate of smoke. In this model, you have m, which is equal to the mass flow rate of smoke entering the smoke layer, measured in kilograms per second. Qp is the convective heat release rate from the fire, and Z is the clear layer height, measured in meters. This formula also has the new variable Z0. This is a figure that is used to give a starting point for the model. It is the height of a virtual source fire above or below the actual fire base. If you look at this diagram, you can see Z0 represented relative to the fire. The cone that spreads upwards from the height Z0 represents the model's outputs for mass flow rate of smoke. The outputs for this model have been found empirically to bear a close relationship with the actual smoke flow rates. If the value of Z0 comes out to be a negative number, then the equation still holds true. What this would mean is that the virtual source of the plume is below the actual fire base, as shown here. CIBSE Guide E has one other thing to say about this second equation. It says that the value of Z0 is often very close to zero, and therefore the equation can be truncated to the equation you see here. This issue is still a matter of ongoing discussion, and in general, it's probably safest to stick with the longer version that includes Z0. So how do we calculate Z0? Well, there's a simple formula, and it's shown here. In this formula, Z0 is measured in meters, ds is the longest dimension of the fire in meters, and Qp is the convective heat output of the fire in kilowatts. So let's do an example of calculating Z0 and then subsequently the mass flow rate of smoke using that figure.